Okay, run through the data in SPSS. The data has been entered. The SPSS file is available on Blackboard. So I'm just going to run through the way you do this in SPSS. Okay, so let's do Analyze, General Linear Model, Repeated Measures. I'm going to call this time. And there are 4 levels. So I have 4 variables that I need, right? So I have to tell SPSS because in SPSS, every row is a subject and every column is a measure of the subject. So in a repeated measures, I've got my variable is time, but I have 4 levels to that variable: T1, T2, T3, T4. So I have to create a variable with 4 levels for repeated measures. So what I got to do is I got to tell SPSS I'm creating a variable time. That variable has 4 levels, and I will select 4 variables from my data set that represent the 4 time measures, the 4 periods in time when I measured each of my 5 subjects. So I'll call it time. Then it's going to ask me to define and say which ones do I want. Well, I want my pre-test, post-test 1, post-test 2, and post-test 3. And then I'm done. And then I run it, and I get my output. Now, we're using a univariate technique. There is a multivariate analysis of variance. The multivariate method is less affected by diagnostic issues in terms of assumptions, but it's statistically less powerful. So it's harder to get a significant effect using the multivariate test. So the preferred method is to go with the univariate test. And that is this one right here. Okay. So you're going to see a lot of stuff here. Now, it doesn't have the complete source table. Every procedure in SPSS was developed. A lot of them were developed by different people. This is the method that they presented. So all they're really telling you is the key sums of squares that you need. You need your time, which is your treatment, and your error. Now this replicates what we had in our source table. So here's our source table right here. Right here. And if I look at that, now if I go back to my SPSS, 520, 1190. Well, the key ones I have is the 520 and the 124. 520 and the 124, right? So from SPSS is only showing this and this. Those are the only ones it's showing. Okay, so it does, and the degrees of freedom as per 3 and 12. Our F observed is 16.78 and P less than 0.05. So I reject the null. Okay, now you're seeing something here, sphericity assumed. I talked about it before. Sphericity is the assumption that our error is random, right? There's no patterns to the error. So the sphericity test is a test that to determine if there's a lack of if there's non-randomness or some kind of pattern in our error term. So it's a test. Once again, SPSS is a bit of overkill. So significance here, I just look across. So the test, which is Macaulay's, or the approximate of Macaulay's is a chi-square, significance is 0.584. So because it's not significant, we don't have an issue with non-normality. So we can go to the first row of our source table, right? So time, sphericity assumed, 5 and 3, 173, 124 and 12, 10.33. The 173.33 divided by the 10.333 gives me my F observed, P less than 0.05. Now, if this significance for sphericity here had been, if that had been less than 0.05, I have to make an adjustment. And my adjustment is, I've done it before. You can pick one. I usually go with the greenhouse geyser. That's one that's typically used. So in that case, I would still report my degrees of freedom and such, but I would report my p-value as 0.003, and sphericity wasn't assumed, and I use the greenhouse geyser adjustment. Right, now you can see how it adjusts the degrees of freedom down. Much like with the t-test, if the your standard error in terms of the variances are not the same. Right? It's the same idea. So it knocks it down from 3 to 1.716 and 12 down to 6.84. Now, as you can see, they differ in terms of how conservative they are. The bigger the damage to my degrees of freedom, the harder it is to reject the null. The lower bound one takes the 3 degrees of freedom down to 1, and then the lower bound for the error takes it down to 4. That's a dramatic difference, which then reduces my significance to point. It's still significant, so I'm off to the races. Here's my F-test for my trend analysis from our plan comparisons, which replicates what we had in SPSS or in Excel. So it's very much the same. Now, the only difference you're going to see here is the is going to be the F observed. So you can see how it's 24.44, and we're showing an F observed of 46.839. The reason is that you can see there's an error term for each plan, each comparison. So if we look at the lecture notes, there is an issue in, this walks us through here, but what I want to get to is here. So as I can see here, there's two ways you can do this. You can do it as we've done it in Excel. You just use your mean square error from your source table, or you can calculate a mean square error on your own, right, in terms of just treating it as a single analysis. I have the link. Howell is a statistician who wrote a book. His book was Statistics for Psychology. And as you can see in the quote, the traditional approach is to grab the error term from the overall ANOVA, which we did when we did our trend analysis in Excel, and I showed it on the calculations, and use that in your F-test. I am not recommending that approach here because it is too sensitive to violations of assumptions, particularly the assumption of sphericity. If you can convince yourself that this is okay, then go back and recalculate results by hand, substituting MS error. Okay, so what we're saying is, because the sphericity was fine in our analysis, I'm okay to do it the way we did it, using the error term, this error term of 10.33 from the source table. Okay, now, there's nothing to stop you from going with what Howell said and using the trend analysis from the SPSS, where there's an error term calculated, error mean square calculated for each of our trend plan comparisons. Voila. Test of betweens, intercept, you can ignore all this. So your focus is this table here for your, if you're looking at the trends, and you're off to the races. Okay. So, now, because of the way it's done here, we're stuck with the trend analysis based in terms of plan comparisons that SPSS provides. And more often than not, you're really, particularly in psychological research, you're not going to use it. So what you can do is in your own data, you can complete your own trend analysis. Now, if we look at our, let's go back to our plan comparisons. These are my trends, right? So I have this here. So what I can do in SPSS is I can replicate the what we do in SPSS in what SPSS does in terms of repeated measures. I can hand bomb it by creating my own plan comparison. And what I'm going to do is I'm going to take the coefficients. Oh, come on, little puppy. Oh, stupid thing. It just won't let me. That's cool. Look at that. That's a flaw in Z program. Okay, so I'm going to do this. I'm going to replicate these coefficients in a compute. I'm going to do this for every subject. So I'm going to call it linear. And it's equal to -3 times by pretest plus -1 times by post-test 1 plus 1 plus 1 times by post-test 2 plus 3 times by post-test 4. Now in this compute in SPSS, it's going to do this. So minus 3, minus 1, plus 3. It's going to do this calculation, add these coefficients to each of the values for each subject. So each subject, right, so for the first subject, it's going to be minus 3 times by 56 plus minus 1 times by 65 plus 1 times by 67 plus 3 times by 76. And then I'll do that, and you'll see it's going to create a linear value for each person, taking the weights to each person's score. Okay, so now I look. There's my linear. Now what I can do is I can run that as a single means t-test. My single means t-test, you can see my p-value is 0.08, which is identical to the p-value for the linear trend from SPSS. Now, SPSS did it as an f-test. I'm doing it as a t-test. So now if I take that t observed, and I know that the relationship between an f and a t is the f is equal to the t squared. Okay, so let's just put that here. So my t observed, t linear is equal to this. Make it f linear by squaring it, which is 24.44. If I go back to SPSS, there is my 24.44. So I did that calculation. I can actually create and replicate the plan comparison from the trend analysis linear from SPSS in terms of the tested within subjects contrast, which is hard coded for SPSS. It's hard to get out of. I can, and when I want, I can run it as a single means t-test. Now what this means is I can do all three comparisons. So now how I would do that is the easiest way to do it in SPSS is to paste it and create syntax. So I'm going to have three comparisons. So I have linear, quadratic, and cubic. I just have to now put in those coefficients that I have for those from my table here. So now this is a nice little screen. So now for the quadratic, it's plus 1 and minus 1, minus 1, and plus 1. That's for the quadratic. The cubic is minus 1, plus 3, minus 3. Once again, these are hard-coded. Like, you don't change these coefficients, and plus 1. I know I've got the plus sign in there. It's kind of redundant, but it just makes it look cleaner. So now I can just run this, and it will create the data. And there I have it. So now when I do my t-test, I can now add the quadratic and the cubic and go OK. And now I have my three t-tests. Here they are. So I can take those. Let's just take, there we go. I'll bring that over to Excel. And let's see. So here are my F observes. And let's just pump that here. So these are the T observed. And then if I square that, let's just put it where we're going to do it. Control X. Sorry. See observed. Now if I square them, that's equal to this hat 2. And now if I compare that to my source, my output, let's blow this up a bit. And I see here and I have my F observes 24.44, 2.353, and 5.92426. Oh, this one's a little off. I don't know why. Okay. So key thing is that if need be, you're not stuck. If you want to do plan comparisons, you can do it this t-test method in SPSS. And that means I could do things like compare the time T1 pretest to the 3 post tests, compare post test 1 and to post test 2 and 3, or I could do like I could compare pretest to the 3 posts, and then I could do like a linear trend and a cubic trend or a quadratic trend for the remaining 3. So I could funk it up a little bit. But the key thing is that you're not stuck using SPSS's hard-boiled method. Okay, I think that covers it for SPSS. We did our diagnostics, our trends, perfect. Okay, so that ends it for our SPSS